关卡，但这个上面就很流畅。And that's exactly why steel producers around the world continue studying nitrogen alloy. Yes. And the next part, let's talk about one area where nitrogen is particularly important. The stainless steel. Yes, special steel, the stainless steel. Many people know stainless steel contains chrome, and some grades contain nickel. But fewer people realize nitrogen can also play an important role. Now, imagine you are producing the stainless steel. You want corrosion resistance, you want strength, you want durability. Yes, at the same time, you need to control the costs. That's not easy. Yes, that's not easy. Every steel producer faces this challenge. And this is one reason why nitrogen containing stainless steel have become increasingly popular in certain applications. Yes, that's why. Because nitrogen can contribute to performance improvements. And when performance improves, engineers gain more flexibility in alloy design. Again, the key point is not simply add nitrogen. The key point is use nitrogen intelligently. Yes, the key point is use nitrogen intelligently. And that's nitrogen. That's for nitrogen and uh, stainless steel. And then let's discuss another important topic. Yes, we have mentioned many times the wear resistance, the nitrogen, and wear resistance. Think about mining equipment, the excavator parts, the crusher components, and the industrial machinery. These products operate in harsh environments. This products operate in harsh environments. They experience the friction, the impact, and the abrasion. Yes, they experience this harsh environments every day. And now imagine two components. One wears out after after 6 months, and the other lasts much longer. Which one would customers prefer? Of course, the answer is obvious. Longer service life means maintenance costs, active product productivity. Yes, that's what longer service life means. This is another reason alloy design matters. And nitrogen can become one of the tools engineers use when. Hello, Fiona. Hello, Peter. Hello, Tina. Yes, nice to meet you. Good afternoon. Okay, now just we discuss the nitrogen with the wear resistance. Yes, and now let's continue. Let's continue today. Money in that we will discuss the nitrogen and the high strength steels. High strength steels. Yes. Today, many industries want lighter but stronger materials. Think about transportation, think about engineering structures, and think about the construction. Years ago, the solution was often simple: use more material. Yes, need more strength, make it thicker, make it heavier, and then problem solved. But today, that's not always practical. Yes, not always practical. Now, more materials means more cost, more weight, and higher transportation expenses. Modern engineering often requires the maximum what modern engineering often requires, and that drives the interest in adopting the nitrogen alloying. Yes, the nitrogen alloying is very important for modern engineering. So now, if you you'd remember, yes, nitrogen is not magic. It doesn't instantly transform poor steel into excellent steel. That's not nitrogen is one tool among many. Think of it like cooking, and if you are making a meal, one ingredient. Yes, you need good ingredients, the proper cooking, correct things, correct timing, and correct temperature. Steel making is exactly the same. Nitrogen helps, but it must work together with the manganese, the silicon, the chrome, the process control, and the temperature managers. Uh, only nitrogen can't work. So we have discussed the nitrogen. What happened? What what happened? Huh? 怎么没了？哪儿也没动啊？Hello, hello. Can you hear me? What happened? 重新驱动，这是怎么搞的？天呐，不是连接着的吗？这出了什么问题？什么都没有啊。 Okay, then let's continue. Just now we have discussed the nitrogen and nitrogen for manufacturers, and we can do. And now the part. Now this part, uh, we can we can uh, talk about today's product, the silicon manganese nitride. Yes, at first glance, the name sounds complicated, but actually it's very logical. Let's break it down. The first, for its name, the silicon, the manganese, the nitrogen, there's three components. Mm. There's three components and three functions. Wait a moment.
是，如果查到卡不到的话，就去刷新才页面就行。
上线它不是已经结束了吗？这半个小时。主要是它这个 OSB 不是 OBS，它空白了，所以它啥都没有。
只要不是网络问题，就关了直接重新再开一个就行。
嗯。
这都是啥问题？
行。不过这个上面为什么也是才10？
你这个，你别看 OBS，你只要看到那评论。
我开的是 Facebook。
这个。
这哦。
这个。
刚才那啥。这个上面怎么才15分呢？我都已经。
半个小时了。
半个小时。
他那个直接断了。
就是行的时候还行，不行的时候就很不稳定。嗯。他刚才说要重启才能应用设置。我这个是真清啊，这个画质。之前那个画质就不太清。网的问题。这还能连上。嗯。可以直接从我这个上面打开。哦，这个什么意思？我给他弄一下。它这个感叹号啥意思？
知道。
哦，这样。那继续吧。Hello everyone, let's continue. Okay. Now, just now we understood why nitrogen matter, and now let's talk about today's product, the silicon manganese nitride. Yes, at first glance, the name sounds complicated, but actually it's very logical. Yes, it's very logical. Let's break it down. First, from its name, the silicon, the manganese, and the nitrogen. Yes, three components and three functions. One alloy. Now you may ask, why combine these elements together? Why not simply add them separately? Yes, that's a very good question. And the answer has everything to do with the efficiency. When steel plants use the silicon manganese nitride, they are not only adding the nitrogen, they are often adding the uh, nitrogen gas, the manganese, the silicon. At the same time, uh, yes, they adding nitrogen, manganese, silicon at the same time. And now let's look at the manganese first. Most steelmakers already know manganese. Manganese is one of the most widely used alloying elements in steel production. Why? Because manganese helps improve the strength, the harden ability, overall steel performance. So, if a steel plant needs manganese anyway, and also needs nitrogen, the silicon manganese nitrate becomes an interesting option. Yes. And then we can talk about the silicon. The silicon is also familiar to most steel producers. Silicon is often associated with the dioxidation, allowing strengthening process control. Again, many steel grades already contain silicon. Nitrogen is nitrogen, manganese, and silicon, and one alloy provides all three, the three elements. Suddenly, the alloy starts making more sense. Yes, it's not simply about adding nitrogen. It's about improving alloy efficiency. Yes. So, for nitride like manganese, yes, we just this discuss about it. We just discuss about its its this its sense. Yes. Now let's discuss specifications because the buyers always ask about specifications. One of the first question is what nitrogen content do you supply? Common grades may contain around 18% nitrogen, around 20% nitrogen. That depends on customer requirements. But here's something important. Experienced buyers don't only look at the nitrogen content. They also they also care about the recovery rate, the consistency, the partial size, and the actual performance. Because Ultimately, steel plants care about results. Yes, steel plants cares about results and not just numbers on a certificate. So now let's move into a very important question. Why do steel plants choose the silicon manganese nitride instead of other nitrogen sources? That is not a theoretical question. This is a real purchasing question because in real steel plants, engineers are not asking what is the silicon manganese nitride. They are asking which nitrogen source is more suitable for my um, more suitable for my production. So let's compare in a very simple way. We will not go to technical. We will focus on real production thinking. Guys, with the silicon manganese nitride. Let's start with the most basic one, the nitrogen gas. Most people think inject the nitrogen gas. That sounds logical, but in real production, it's not that simple. When your nitrogen content is different in every heat, what happens? You get unstable product quality, yes, and unstable mechanical properties, and unstable customers feedback to control. So we choose to control. So we choose the silicon manganese nitride. Yes, and now compare silicon manganese nitride with silicon manganese nitride. Nitrogen is already bound in solid alloy form, and it enters the steel in a more controlled way. Reaction is more predictable. So the difference is very simple. Nitrogen gas means direct but unstable. The silicon manganese nitride is why we choose the silicon manganese nitride. And then let's talk about